Hello everyone, today we're going to be querying dates within CosmosDB, and in doing so we're looking at this date format over here, which is the ISO 861 UTC standard. So this is the recommended format that CosmosDB expects us to input when we're querying dates, and looking at the format would then bring us this value here in green. But then our question today is then how do we query dates that are stored within CosmosDB that are not adhering to that format? So jumping into CosmosDB, we can see that we have this demo data, which has the date format within day, month, year. And when you notice that data, what we see is that when we try and query or run where queries or try and run any computations across that data, we don't get values that align. So in this one example here, where we're trying to pull all the release dates that are earlier than a given date, we would find that some of the results don't necessarily match to that format. So what we're trying to do is then to make sure that the date format is aligned so that we can query dates and get back accurate results. One example we did was to just try and parse the dates using a UDF, a user-defined function, that would take the date string as an input and via JavaScript just return a new date object. So jumping back here, I'm doing a top 100 and taking that user-defined function and passing in the release date and seeing what we get here. So let me run this. And once the result comes through, we can see that the dates also are here as well. Some of the past dates are null, which is what we'll get into, but then you see other dates here, they come in the required format, but then you would see that it's year, day, month. So if you pass the date just as it is, it would then spin or flip the day and the month values. So what I'm going to do is I'm going to try and query one of these dates here to see if they're actually valid. So what I'll do is I'll take one of these movies and try and confirm if this past date is correct. So the release date is showing the 7th of February 1976, but the past date is showing 1976 July 2nd. So I'll take a taxi driver here and I'll query the results. So then looking at taxi driver, you can see that the release date is the 8th of February 1976. So given the 1 day difference, this past date is incorrect, which means that the month and the day date parts have been switched when trying to parse the date, so we can't use this TryParse function. And what we'd also see is that because the day and the month have been switched, where the day is greater than 12, the parse function can't actually parse greater than 12 months because there aren't more than 12 months. So if it's greater than 12 here in front, then you would see that it's null here. But if the month is less than 12, that's where you see it actually comes in as the 11th for the month. So that's why we're getting nulls for some of these parsing function. So again, we can't use this TryParse function. Instead, what we're trying to use is this date to ISO function, which takes an input and the separator, so the actual date text as well as the value that separates the date parts, and we're going to take the date parts, split them into their own little objects within the array, and then we're going to reverse the array. So where it was day, month, year, it will then bring back year, month, day, and then we take that and try and pass it into a date value and see if we get any results. So here within query 3, what I'm doing in this select statement is that we're selecting the release date, we're selecting the past version of the release date, which is to take the date and the separator, which is that // and then we're going to take the ID as well and run this query. We've got a comma. Okay, and once the query runs, we can now see that the dates are aligned. So the release date is the 21st of October 1988. Here we have 1988, October 21st. So now we're able to get that date format that we spoke of in the first slide. Now what's interesting is that if we now run this query to query all the movies that are older than a certain date using the UDF, we'll then be able to get a more accurate result set. So here we go. This list is just the release dates, but you can see each and every one of them is before the year 1992, if not on the year as well. So that's how we would do it. But interestingly enough, if we had to just query year, month, day, and see if that would bring an accurate result, we would see that the result is true. So you do have that option just to play around to see if the year, month, day will bring back accurate results. But in a nutshell, using this UDF function allows us to mask the date so that we can get accurate results. So in the slides, how to query dates that are not in the recommended format, we would basically use a user-defined function. And that's only if we're querying data that is not in the incorrect format. There might be other ideas in terms of reloading the data or formatting the data with some kind of stored procedure. But for this case, CosmosDB, we're able to mask alternative date formats using a user-defined function. But there will be more examples that we can look into in future videos.